An MRI? Well, isn't it something medically? A scan? Yes. However, MRI, magnetic resonance imaging, utilizes a lot of physics and chemistry to provide us with an accurate representation of our biology. To see how it works, we go to the simplest available atom, the hydrogen atom. This is a hydrogen atom. And since the proton, which is a charged particle, also keeps spinning, it generates a magnetic field, also known as the magnetic moment. When placed in an external magnetic field, these atoms align their magnetic moment along with that of the external magnetic field in a parallel or anti-parallel fashion. The rate at which these protons spin around themselves is directly proportional to the strength of the external magnetic field. This is the general structure of an MRI machine. The blue cylinder you see is an extremely powerful electromagnet, inside which coils are placed parallel vertically and horizontally to each other, shown as red and yellow. These are responsible for producing slight changes in the magnetic field on the inside, which is responsible, as we saw, for the rate of rotation of a hydrogen atom. This allows us to take pictures along various axes. The green coils are also gradient coils, which allow us to take images along the z-axis. Further, the orange colored rods we see running along the cylinder are radio frequency coils. They are responsible for triggering the antiparallel parallel alignment of the hydrogen atoms along the magnetic field. How? Let's see. Upon application of external magnetic field, we know that most of the atoms align their magnetic moment with that of the external field, and that parallel moment, such as this, will have minimum energy, whereas anti-parallel moment, which is these arrows will be upside down, shall have maximum energy. The radio frequency coils now fire momentarily to excite one of these atoms to an anti-parallel state. But since this anti-parallel state is extremely unstable and has great amount of energy, the atom tends to return to the parallel state. While doing this, it releases energy in the form of radio frequency, which is detected by the radio frequency coils again, which allows them to form an image of what happens inside our body. Since our body is made of 70% water and most of the fats we crib about reducing are made of carbon and hydrogen, the MRI can take a clear image of what goes on inside our body. Additionally, since it uses no ionizing radiation, this is one of the safest methods to take complete scans of our body for those who have no medical implants.